In this video, we're going to look at how to prove the power rule using the definition of a derivative. The definition of the derivative, first of all, of course, is the regular old, it's the limit of a slope. We've got rise over run. Of course, as h goes to 0. And the power rule, just to review, is that when we take a derivative, dx of a times x to the some powers, we'll say b, then what we get is, of course, a times b x to the b minus 1. So, let's prove this. First of all, we'll start right here. We simply plug it right in. So we have the limit of a times x plus h to the power of b minus a times x to the b all over, well, x minus x, that cancels out, we just have h, which is usually how we see the definition written. Okay, well, the trick here, what do we do from here? We don't know what b is. B might not even be an integer, much less a rational, might not even be a rational number. So what are we going to do here? We are going to use the binomial expansion. Binomial expansion tells us, there's a little bit of room to work here. That is, if we have, I'll say, x plus h to some power, then that's the same as sum from b, we'll say k equals 0. And this goes back to the time of Newton, if I recall. B over k, x to the b minus k, h to the k. Okay, now, fortunately for us, we only need to worry about the first few terms. We don't need to worry about everything here. This will certainly work for integer values of b. Come to think of it, I'm not certain it would work for non-integers. It's a very interesting question. I'll have to think about that. In any case, for the expansion here, we'll have x to the b. We'll have, now if b is, or b is b, k is 1, we'll get, let's see, what will we get? We'll get b times x to the b minus 1, h to the 1. Next term would be b minus 1 over 2, x to the b minus 2, h to the 2, dot, 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 so on. Sorry. However, these higher terms are not going to be significant for us. Let's take a look. Let's plug it in. So we take what we originally had, right here. We're going to replace this. First of all, let's get this a out of the way. This is just, a is just complicating things. We'll write in, different color, pull the a out, put our limit in. Limit as h goes to 0. And we have, we're going to replace this guy right here with this. So we have b, x to the b, plus b, x to the plus 1 times h, plus b minus 1, 2, x to the b minus 2, h squared, dot, 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 so on. I also need to include our minus x to the b. So minus x to the b. All of this over, of course I'll close my parentheses over here, all this over h. First thing to simplify. X to the b minus x to the b. Cancels out. Okay, what does that leave us with? That leaves us with a fresh sheet of paper. Never be afraid to use a fresh sheet of paper. Keep this nice and clear by using extra sheets as necessary. Okay, so we have a times our limit as h goes to 0. What we have left is, let me put this up here. What we have left is b, x to the b minus 1 over h plus b minus 1 over 2 x to the b minus 2 h squared and higher terms all over h. Now this term right here, h over h, is going to cancel out. Over here, our higher terms will lose a power of h, but we still have an h, which means that a limit b x to the b minus 1 plus a bunch of terms that have higher powers of h and other higher powers of h. If h is going to 0, hasta la vista, which means we're left with a times b to the x times b to the b minus 1, which is exactly what we said we should come up with. Thus we have the definition of a power rule. Thank you.